Hello viewers, we are going to learn about Common Bus System in Basic Computer Organization and Design. Common Bus System, it provides communication path to transfer information from one register to another and between memory and registers. The main advantage of using Common Bus System is that it avoids excessive use of wires, particularly when a computer is designed with multiple registers. Here in this figure, there are 8 registers and 1 memory unit are connected using a common bus system that is constructed using 3-input multiplexer. So, this common bus system, it helps the 8 registers and 1 memory unit to transfer its information between them. Okay. Here, if you observe this figure, though there are 8 registers are there, only 6 registers transfers its information over the common bus. The input register and the output register, they do not send any data to the common bus. Okay, because input register, whenever it receives information from input device, it transfers its information only to the ALU unit. Similarly, output register, it sends its information only to the output device. That's why input register and output register do not send any information over the common bus. Whereas here, whenever the information passed over the common bus, out of these 8 registers, only 6 registers can receive the information. The input register and the accumulator, they do not receive any information that is passed over the common bus, because input register, it receives information only from the input device, and accumulator, as we already discussed, accumulator, it is the general purpose register where one of its operand is taken for the ALU operation, and after the ALU operation, the result is also stored back into the accumulator. Okay, so that's why the accumulator do not receive any data directly from common bus. Okay, um, so let us now discuss the very important 2 points on common bus. So though there are 6 registers and 1 memory unit are connected to the common bus, that is, out of 6 registers and 1 memory unit, one of the component only can transfer its information over the bus. Okay, at a time only one of the component only can transfer its information over the bus. Okay. Very similarly, out of 6 registers and 1 memory unit, one of the component only can receive the information passed over the common bus. Okay. Let us now discuss who can send the information over the common bus and who can receive the information that is passed over the common bus. These two are the very important point in common bus system. Okay. So here you can observe the decimal numbers are specified along each register and memory unit, right? These registers, these numbers are the decimal equivalent of the binary values of selection signals. These decimal numbers are the decimal equivalent of the binary values of selection signals. Okay. For example, if selection signal values are 100, so since 100 is equivalent to 1, okay, since 1 is specified along AR, that is address register, so it has to immediately, whenever the selection signal values are 100, then immediately the address register has to transfer its information over the common bus. Okay, and if suppose instead of 100, if suppose the selection signal values are 111, so since 111 its decimal equivalent to 7, So it is specified along memory unit. Okay. So now the memory unit has to transfer its information. For memory unit, along with selection signals, its read signal also need to be enabled. So when read signal as well as the selection signal values are triple one, then only when read signal is enabled and selection signal values are set triple one, then only the memory unit can transfer its information over the common bus. So just assume that by setting the selection signal values, one of the register or memory unit has transferred its information and it is passing over the common bus. Now we have to discuss about the second point. So now who has to receive the information passed over the common bus? Who has to receive? So that is determined by setting the load signal of the register. Load signal of the particular register, who has to receive it. If suppose memory has to receive the information passed over the common bus, then its write signal need to be enabled. Okay, so either by enabling one of the register or else by enabling a write signal, uh, the processor makes the particular component to receive the information passed over the common bus. Okay, let us now discuss how this data transfer happens from. Let us now discuss how information is passed from address register to program counter. To achieve this register transfer, from where the information has to be transmitted from address register. So the passed information must travel through the common bus and it has to be received by the program counter. Okay, so to achieve this information transfer, first selection signal values of address register. Since address register number specified along address register is 1, the selection signal values need to be set 100. So immediately whenever the selection signal values are set 100, it will transfer its information, and since program counter has to receive it, whenever it is passing over, immediately the program counter it will receive the information. Okay, so like this, any data transfer or information transfer can happen between the register and between memory and registers. Okay, students, and in addition to these important points, a few more points also can be discussed. Here you see the address register and program counter registers size are 12, right? So, but our common bus system size is 16-bit size. So, whenever this address register and program counter registers are transferring its information, the first four most significant bit values are set to 0, then the information is passed over the common bus. So whereas whenever they receive the information, only the program counter and address register they receive only the 12 least significant bit information. Since output register its size is 8 bit, and whenever it receives the information from common bus, only it receives 8 least significant bit information from the common bus. The one more important point to be discussed here is that you can observe in this diagram address, this line is the line from address register is permanently connected to the memory unit. So since we know that in memory instructions as well as operands are stored in the same memory unit, whenever a particular instruction or operand is read or returned to the memory unit, in both cases, memory location need to be known, right? So to keep track of the memory location where the read operation or write operation is performed, it is maintained by the address register. That's why address register need to be permanently have a connection with memory unit to keep track of the location where a memory operation, read or write operation takes place. Okay. These are the important points about common bus system. Students, if you find this video useful to you, kindly subscribe this channel. Thanks for watching.